This is Jacob Nash with JNGL. Today, this is a new unit that I started on this PowerPoint thing, and it is Unit 4. And the main title of it is really just trigonometry. And if you've heard of that, it's not as complicated as it might seem. And this is just Lesson 1 about 4.1. The thing about this unit is that there are 5 standards, and 2 of them are only for a CP class. So some of them you might not have to watch if you are a CP student. Okay, introduction to trigonometry, Trig. Well, it is just, all trigonometry is really just triangle measurements. And trigonometric ratio is a ratio of the length of 2 sides of triangles. So you know what a ratio is. It's basically just a comparison. It might be like this. That is not big enough at all. Undo. There's no Control Z for this. That's usually what I do to make things faster. Okay, but and that's big, but too bad. Okay, that's kind of like a ratio, so it's just comparing, but it also might be on top of each other like this, and that's what the case will be for this. So the common ratios are sine, cosine, and tangent. And now back small again. I will underline certain things, and they might remind you of something that you've maybe seen your whole life of being on a calculator. I don't know if you've ever noticed on a calculator that it says sin, cos, and tan. Well, really what those are just things that have to do with trigonometry. And, oh no, that's not good. Hopefully I finished the video before my device dies. Yes. So that's really what it is. Those are the things that are on the calculator. So let's show them on the calculator. Whenever you're going to use these function buttons, you can push those buttons. But the thing that's strange about this is that certain things can happen to a calculator that will make these buttons mess up. And if you ever see, on your calculator screen, I should put a picture, but on the screen where it will say your answer, if your answer was 8, it might say, somewhere, over here to the bottom right, or maybe up here, it might say, grad, deg, or rad. And if it says any of those things, when it's on rad, that's what you want for algebra. But if you're doing these trig functions, you want to do deg. So if you don't have it on that, then these things will mess up. So you have to make sure it's on that. And then press second button, and then sin, cos, or tan to get the sin to the negative first, the cos to the negative first, or the tan to negative first. So that's right above them. If you can see, right here, sin, cos, tan. And I actually made the tan right here outlined in tan because I thought that's a good thing to do. Anyways, when you're talking about these, you'll usually want to say, you'll want to refer to them by their full name, not really just their abbreviation. That's just kind of how it is. That's what that is, yes. And here's a tricky thing. Sohcahtoa. That's a thing that there is that can help you remember certain equations for your sin, cos, and tan. So usually when there's math, there's usually some kind of Greek thing going on. So a Greek letter pi, you know that's used in certain things. What's something else? I don't know. I mean, sometimes you might use the you might use I forgot what that one was called, but you might use that thing. But almost everything that you'll learn about traces roots to Greek or Roman things. So, but anyways, that's why we're using these equations. The way that your teacher might write these equations might be different. They might not use these Greek letters, but the Greek letters look like U, A, and Y, but they are not that. And it's important that you know that they're not that, because if you can tell, this A looks a little fancier, but you might get mixed up. But anyways, the equation for sine is going to be alpha over duction. That you pronounce the U looking one like diction, and it represents hypotenuse. And the A is alpha, alpha, omega, that kind of thing. Opposite side. And then this Y one is kalma, and it means adjacent side. That's what those words stand, or that's what those that's what those Greek letters mean. So when you're doing the sine, it's going to be alpha over diction, or opposite side over hypotenuse. And that's what this whole Sohcahtoa means. Or sorry, Sohcahtoa. That's if you say it that way, then it makes it seem more like what it is. But if you see sine, opposite side, hypotenuse. And then cos is going to be calma over diction, or adjacent over hypotenuse. So cosine, adjacent, hypotenuse. And then the tangent will be alpha over calma, which is tangent, opposite, adjacent. Well, you might think like, okay, I kind of forgot what a hypotenuse is. If you did Unit 3 already, then I guess you shouldn't not know what that is. And you probably should know what these words mean too. But in case you don't, what it will mean is that there will always be a reference angle, and from there, that will determine what it is. Looking at different points of views from each angle will change which angle or which side is going to be the opposite or adjacent. So if we're from this red angle's perspective, well, any angle's perspective, always the longest one that goes like that is going to be the hypotenuse with the diction. Or sometimes it's an abbreviation, HYP. That could be a thing also. And then from this red angle's point of view, the one that's opposite is right on the other side from it, which is going to be the alpha. That is really not good. Okay, I really don't want this to die, so let me try to hurry this up. I haven't actually gotten into any problems yet. Okay, and which is opposite side, which might be OPP, and then Y, or sorry, calma. That's the adjacent side, because it really, what the adjacent side is, you might say, oh, that's adjacent too. Well, it's the hypotenuse, so whichever one's not hypotenuse, that's the adjacent one. Okay, good. Finding ratios. Hang tight. You might want to skip the video a few seconds, because I'm going to actually go get the thing that charges this. Okay, hang on. Sorry about that. Too late. Okay, I'm back. I'm plugging into the outlet, plugging into the port, and we're not charging for some reason. The outlets are stupid in this house that I live in. Alright, it's charging now. Sorry about that. Let me see here. Okay, finding ratios. Remember, if the video stops, there's another part that might happen on this one. Okay, sin. Oh, sorry, sine. Anyways, I myself call them by their abbreviations by accident, but you should not do that. All right, finding ratios. Well, here's what you are going to be doing for this. Well, let's see. Okay, well, we do have to have a reference angle, and those are not in here. So let me add them. Let's call the reference angle for this one this green angle, and the reference angle for this one will be this blue angle. Actually, the one with the blue angle is the one you're going to do after you find out how to do this one. So here's how you find the sine. Alright, so when you're doing the sine, remember, Sohcahtoa. So that's going to be A over H, which is adjacent over hypotenuse. And if we go back to our Greek letters here, that is the alpha over diction. But we can just say A over H for now. So what is the A? Where? You know what else? The side links are missing. So let's add in those. I will put 14, 12, and 6. Sometimes you might have to find it, and if you had to do that, you would use Pythagorean's theorem. But anyways, so let's try. The A is going to be adjacent. The adjacent is the one that's not the hypotenuse and it's not opposite, so it's the 6. So it's going to be 6 over something, either 12 or 14. Well, if it's a hypotenuse, so that's 14. So 6/14 is the ratio. You might want to do that with the colon, if that's what you need to do. All right, cosine is going to be Sohcahtoa. Oh, wait a second. Sorry. I knew I messed something up. This is what's for the cosine. Sorry about that. If you're gonna remember that thing, you have to remember it right. Unlike what I did. Say eraser. It's gonna be different for this one. Okay. Alright, so actually it's gonna be O over H. So still over 14, but this time we put the O for opposite, which is the 12, which is the alpha. It's gonna be over here. That's the opposite side. And then tan, is going to be the O over A. So O we know is the alpha 12, and then the A is going to be our 6. Well, here's something you realize about this one. You gotta still simplify, and this simplifies to 2 over 1, but we will just say 2. Well, actually, never mind. We would not say just 2, because when you're doing a ratio, you would have 2 numbers. So, sorry about that. You would not do just 2. That's what that is. So now that you know that, I will actually have to put side links for this one also. Let's try 13 and 17. Try this one. If you think you know the answer, comment below, and I will answer to you if you have a question about it, but I really just can't do that right now. Alright, finding the missing sides. Well, that's what you'll have to do. When you're wanting to do that, there is a certain thing that you do. Different things that you do if x is in the numerator or denominator when you set it up. So, let's just say we're trying to find we have to find out what you're going to be finding. So, are you going to be finding the sine, cosine, or tangent? Well, we have a reference angle, and the reference angle is going to be the one that's labeled. The 90 would not work because here's why. If you ever use the 90 angle as a reference angle, you would notice that the opposite and hypotenuse would be the same thing, and that would just not work. So 41 degrees is our reference angle, and we just start out with that. This 41. Now we're going to figure out what other angles we have. Well, The one that's adjacent is this one. The one that's hypotenuse is this one. The one that's